chemical bond came up with the Gilbert-Lewis, saying that chemical bonds were due to the sharing of electrons between atoms. Oh, okay. So then come another scientist. Of course, we always have someone to prove different things. And this other scientist, which is Dr. Cosell, says the electrons in the outer shell were responsible for the valence, which is the valence electrons, the electrons located in the last shell energy level, right? So atoms can lose or can receive electrons to be more stable. So when they lose or receive, they form ions, and thus they will be attract each other through electrostatic force. That is the ionic bonding. So valence electrons, so all the bonds happen because the valence electrons. So that is kind of the money that we have in account, not in the savings. So the money that you can use to negotiate, right? So valence electrons is the occupy the highest energy S and P shells, subshells. Remember the electronic configurations. For example, here, let me grab a pen over here. What is my pen? That's over here. So when we talked about the electron configuration, I said, okay, so for example, hydrogen will be 1s1. If you go to helium, so I have 2s2 for helium. If I go to lithium, so I have 1s2 because I have 1, 2, and then 2s1. So the level 2, I only have one sublevel s and one electron, which is over here. See, that is the last shell of energy in this lithium. This is the valence electrons over here, okay? The valence electrons are the ones that are involved in chemical reactions. So my first question, probably it's your first question, is why do the atoms get together? So why do you get married? Why why the elements get together as well? To look for stability. Remember that I said before, chemistry is about movement. So when you talk about movement of electrons, movement of the particles, molecules, remember when you talk about solid gas and liquids, we always talk about movement. And here, like us, we always look for stability. This is why you are studying, right? So you're studying because you're looking for a better future. You're looking for more stability, professional and your life. When you get married, we think like, oh, your life will be better, will have more fun, you'll be more stable, so have two persons, right, together. So that is what the atom is looking for as well, looking for stability, and that is the octet rule. So the octet rule is when the scientists ask themselves, like, why the noble gas are so stable? They don't tend to react. They don't tend to bond with anyone. So why? So why he's so nice and zen, like, ooh, nothing will take out the line. Like, okay, I'm good, I'm fine. So the elements, so when the scientists look at those elements, they start thinking, okay, so the elements bonded together because they are trying to have the same electron configuration of the noble gas. They are trying to be stable, okay? So if, for example, sodium has 11 electrons. So if I have in the first shell, I only have 2 electrons. And the second, I have sp, so we're gonna have 8 electrons around here, and the second level of energy. And then third level of energy, so I already have 10, so I only have 1. So imagine if sodium lose this one over here, let's raise that. Okay, lose this. Sodium will be positive because he lost 1 electron, so he lost the negative negative part, like electrons, right? So it's more positive. So now it's positive, but it's more stable because now the valence electron is completed, right? It's like the 1s2, 2s2, 2p6 has the same electron configuration of neon, so which makes the sodium more stable. And this is why we say the elements bond together, because they try to have the same electron configuration of the noble gas. And you're going to say it's always must have 8 electrons. No, that is the name because most of the elements going to have 8 electrons and the valence electron shells like neon, argon. But however, helium only has 2, like here, so I have 2 electrons. But this is the only level of energy that a helium contains. So the valence electrons are, the valence shells are completed, so it's full. That's why it's stable. Okay, that is the octet rule. So as I said, the octet rule states that the atoms bond in such a way that each atom acquire 8 electrons in the outer shell. So as I said before, hydrogen will have 2 and be happy because that is the only level, the energy level that hydrogen will have, and have the same configuration of helium, right? So atom acquires the octet of electrons by either gaining, losing, or sharing their electrons. So imagine chlorine, which has 1, 2, 3, 4, 5, 6, 7 electrons in the last shell, valence electrons. So it's much easier to get 1 electron because it has a high electronegativity here, right? That chlorine has a very high electronegativity, so we attract the electrons for itself. So if you have another chlorine over here, okay, so this one, we're gonna say like, oh, give him 1 electron, please. And he's gonna say, oh no, I will not give you 1 electron, but we can share. So because if you share, we are both good, like in marriage, right? We share everything. We share the room, we share the kitchen, we share sometimes the car, we share a bank account, right? So here is sharing. So now if you look at here, I have 1, 2, 3, 4, 5, 6, 7, 8, and the same for this. So it's sharing. So if you have a electron like sodium, remember, it's easy to give away that electron because now he will be happy. So if he give away electron for chloride, we'll have a negative here and a positive here, then they will feel very attracted to each other because one element give away and the other receive it, accept that electrons. So that is a very strong ionic bond. Okay, so there are 2 ways in which atom may achieve octet, as I said. So transfer of electrons from one atom to another, like I said, sodium to chloride, or sharing 1 or more pairs of electrons, like I gave you example of Cl2.